today and welcome to our webinar. Is tier and down gauging in PE and PP packaging made easier with ViviOn? My name is Marcel Marcos. I'm very pleased to be the host for today's session. On behalf of Mitsui Plastics, I'd like to thank you, every one of you, for taking your time to be with us today. We know your schedules are really busy, and we truly appreciate your participation. Today's discussion will focus on a topic that is highly relevant for converters, packaging engineers, and product developers: how to improve tier behavior of packaging, rigidity, and down-gauging potential for PE and PP structures without compromising recyclability, that today is really important for our market as well. As many of you know, from daily experience, achieving the right balance properties in flexible packaging is never trivial. Improving stiffness can negatively impact tier behavior. Erasing tier can affect processability. Downgauging often introduce mechanical risks, lack of mechanical properties. That's why this material, ViviOn, design innovations without losing these properties and generating strong interest from our packaging customers that all of you here present today. It's now my pleasure to introduce our speaker. We introduce Janice Penn, Project Manager at USI Corporation from the Advanced Material Business Unit. Janice brings extensive experience in advanced polymer materials and application development, particularly in solutions design of high-performance PE and PP packaging structures. Today, Janice will share insights into how ViviOn enables improve easy-tier functionality, down-gauging opportunities, and embrace rigidity with film balance. Janice, thank you very much for being with us today. The floor is yours.
Hi, thank you, Marcel. So hi, everyone. My name is Janice, and I'm responsible for the marketing and sales of ViviOn CBC for USI Corporation. So first of all, I would like to thank the Mitsui Plastic team for having us today. It's a pleasure to connect with all of you. So today I'll be sharing how ViviOn application in PE PP packaging. So now let's get started. Okay, so here's a quick look at our agenda for today. So first of all, I'll start with a brief overview of USI Corporation and ViviOn CBC. Then we'll move into the main focus of today's webinar, applications in PE PP packaging. And afterward, we will have a quick FAQ and then show you a demo video of easy tier performance in actions. And then we'll wrap up with the Q&A sections. Okay, so here comes the brief overview of USI Corporation. So USI Corporation was founded in 1965. So our main business is focused on EVA and PE. We have been selling EVA and PE for more than 50 years. And ViviOn CBC is our new material, which was launched in 2018. So our headquarters is located in Taipei, and our first and only ViviOn plant is located in Kaohsiung City. So its design annual capacity is 5,000 metric tons. And our production started in 2018. And you can see that our packaging line is under clean room condition to make sure that our materials has high purity level. Okay. So here's the brief overview of ViviOn CBC. So what is ViviOn CBC? ViviOn is the brand name of our product, and the CBC is the abbreviation of cyclic block copolymer. And here comes the two main key technologies of our material. The first one is anionic polymerization technology. This one could ensure our material has extremely high purity, which is definitely foot contact level, and could also be qualified for some levels of medical regulation. And the second technology is catalytic fully hydrogenation technology. So this one make the structure of our material could be called as the chemical relative of polyolefin plastic, and which ensures our material has great compatibility with PE and PP. Okay. So here comes the main focus of our webinar today. So today we're going to focus on ViviOn's applications in PE/PP packaging. So for PE/PP packaging applications, ViviOn's role is kind of like an additive or modifier to the PE/PP base formulation. So our suggested grade for this application is A210XT. And the main features are like so after dry blending ViviOn with PE and PP, here's are the benefits ViviOn could bring for PE/PP based packaging. So the first one would be enhanced stiffness, which could also enable film downgauging. And the second one would be reduced tear strength, which could also create the easy tear performance. And the third one is recyclable within PE/PP streams. And for this one, our material is certified by Cyclos HTP, which is an institution in Germany. And later on, I would share more about the applications. Okay, so here's our three main features and the suggested content for each features. So please note that when I'm talking about ViviOn content, it's about the content for the whole structure of the PE or PP film, not just single layer. Okay. So the first one would be the enhanced stiffness. So here's are the data that we would like to show you that how ViviOn could help enhance the stiffness of PE film. So as you can see on the slides, by adding ViviOn to different kind of PE, we could effectively enhance the modulus of PE film, like LDPE, C4, C6, C8, LLDPE. Its modulus all goes up with more addition of ViviOn. And on this slide, this is showing that by adding ViviOn to PP, ViviOn could also enhance the modulus of PE film. So we pick homo PP and random PP. So on this slide, you could also see that with more addition of ViviOn, the modulus of PP film goes up. So I want to share the application that could, the application that really applies the increased stiffness features to the VNCPP film. So currently, this application is our biggest brings the biggest revenue for PE/PP packaging market. So the relative application includes snack bags, potato chips, and instant coffee sachets. So first of all, I would like to talk about the brief structure of VMCPP. So VMCPP is actually a high barrier packaging film that consists of CPP film, which is a soft, flexible base layer produced without stretching, and VM layer, which is vacuum metallized layer. It's a thin aluminum layer deposit onto the substrate, which can help provide the great barrier performance. So why would I say that the stiffness is the key to VN-CPP barrier performance, and why enhancing CPP films stiffness could help protecting VN layer in VN-CPP. So first of all, I would like to talk about the PP subject first. So unlike BOPP film, the standard CPP film is not stretched and lacks the stiffness to support the thin VM layer. And this would lead to help to cause the VM layer on VMCPP to crack during handling, and which would ruins the barrier performance of VMCPP film. So for the solution, so for adding ViviOn to help increase the stiffness of CPP film, it could also help protect the VM layer, which could ensure the superior pinhole resistance and lasting barrier performance. And here's a brief introduction about how to improve it. So this is the structure of VMCPP film. Here you can see that here's the VM layer, and down here is the CPP film structure. So for our previous experience, we suggested could add ViviOn to the skin layer, and which could help increase the stiffness of the CPP film structure. And you can see that usually the skin layer it's only 10% of the whole it's only 10% of the layer distribution of the whole structure. So by adding 40 to 50% of ViviOn to only 10% of the layer distribution comes to the ViviOn content, which is like 4 to 5% of the total structure. And here comes the another application sharing. So another one would be enabling film downgauging for shrink films. And the relative application includes a collation shrink film for a beverage. So we think that for this application, stiffness would definitely be a key to prevent the beverage packaging deformations happens. So the cost would be, so for the beverage brands, they wanted to reduce the plastic use by downgauging shrink films, but they also don't want to sacrifice the performance of these packaging film. And for the challenge would be, we all know that if the film's thickness is thinner, it will definitely lose the stiffness for the packaging, which might cause the beverage containers to shift or lean during the transport and storage. And the solutions we're providing here is adding ViviOn to the skin layers, which could help increase the stiffness of the film and ensuring the packaging stays strong and stable. So for this application, we also suggested the customer could add ViviOn to the skin layers of the structures. And on this application, you could see that the addition for skin layers would be 20 to 50%, depends on the requirement and the target of the customer. And since the skin layers is layer distribution is only 5%, so with two sides of skin layers, the total ViviOn content for these applications would be 2 to 5%. Oh, yeah, and we actually have customer applying this way to successfully decrease their thickness of their collation shrink film from 60 micrometers to micron to 40 micrometers.
Very interesting, Janice. The reduction is significant. I just would like to interrupt a little bit for the audience. Just a reminder that you're gonna have a Q&A session in the end, so please feel free to submit your questions using the chat or the Q&A function. We will answer after Janice finished the presentation. Thank you, Janice.
Sure. Okay. So let's get into the reduced tear strength section. So for the reduced tear strength section, on this slide, you can also see that by adding ViviOn to PE, ViviOn could effectively reduce the tear strength of the PE film. So we pick LDPE and C4, C6, C8 LLDPE. With more addition, you can see that with more addition of ViviOn, you can see that the tear strengths drop more. And you could also probably already see a trend that by picking the PE, which naturally has lower tear strengths, which it doesn't need that much of addition of ViviOn, could also reach the great easy tear performance. So picking the PE selection is also a key for creating cost-effective easy tear performance. And also on this slides, you can see that by adding ViviOn to Homo PP, random PP, you can see that it could reduce the tear strength of the PP film. And with the more addition of ViviOn, the tear strengths will drop more. So here comes the applications that could apply the decrease the tear strength. So the applications will be easy tear sachets for coffee, enzyme powder, and instant noodles sauce. So here is case sharing, which is the sustainable aluminum-free packaging. So we all know that for easy tear packaging, aluminum could really provide great barrier performance and the stiffness and the great tear performance. But the trends become that sustainable packaging is more and more important, and especially for the Europe and America market, this becomes more and more essential. So removing the aluminum from the traditional packaging is becoming key targets for the packaging companies. So here we provide solutions by, we think that for barrier, stiffness, and easy tier performance are the key factor that we need to focus on replacing aluminum layer. So the cost is, the market is moving to recyclable packaging. To do this, we need to remove the aluminum layer. And then challenging would be, without the aluminum layer, the film will lose its great barrier performance, and it will also lose its stiffness and becomes hard to tear. So here we, not only just by blending ViviOn into PE, we also think that the solution has to be combining with EVOH. So by adding EVOH to bring back the barrier performance, and by adding ViviOn into PE, it could restore the stiffness and make the packaging easy to tear in the straight line. So here's so by how to improve it. So ViviOn has to be addition to the PE there. So you can see that their distribution for PE there on this packaging, it's 80 to 90%. And by the addition of 12 to 22% of ViviOn, it comes to the total content of 10 to 20%. Also, why it has a range is because of it also depends on the customer's target and requirement. So here are the regulation and certificates. So for packaging, the material definitely has to be food contact regulated. So ViviOn CBC is qualified for those regulations listed here. The first one would definitely be food contact US FDA food contact notification, and also qualify for China food safety standard and Commission regulations from EU for plastic materials. And also the certificates for PE/PP recyclability. So with the addition, no more than 20% for PE or PP-based packaging, it could be defined as the recyclable within PE/PP streams. So here's just the TDS of our A210XT grade, which is also the grade that we suggested for PEPP applications, PEPP packaging applications. So here's the processing, here's the FAQ section. So this one is probably the most important one, the processing temperature guideline. So our processing recommend processing temperature is actually above 200 degrees Celsius, which is 392 degrees Fahrenheit. And if it's acceptable, higher temperature setting is even better. So according to our previous experience, if the processing temperature is not high enough, it may result in the shark skin appearance on the film or poor dispersion effect to the formulation. So the second one would be the addition guideline. So this is mentioned earlier, but I just want to discuss it again, that because for different kinds of features, we have the different recommend addition to the total structure. So in our experience, usually our commercialized case for enhanced stiffness or enable film downgauging, the total addition for the whole structure usually is no more than 5%. And but this one for reduced tear strength, we do recommend having higher addition for the whole structure. Usually, our commercialized case, the ViviOn content would be 10 to 20%, depends on customers' target and requirement. So just please note it that if you're targeting to reduce tear strength or creating easy tear performance, the content for ViviOn addition has to be a lot more than enhanced stiffness. And the third one would be the recyclable within PEPP streams. This one is actually defined by our certificates. So the certificates was performed by the Cyclos HTP, which is a Germany institution. By the certificates, it shows that with the ViviOn content no more than 20% for the whole structure, the film itself should be seen as recyclable within the PEPP streams. And if your addition is no more than 20%, it should be no doubt could be seen as the monomaterial packaging. And the second point for the ViviOn addition guideline would be we do have the maximum addition level limitation for blown film process. So the maximum addition level for a single layer should be no more than 50% if you are producing your film by blown film process. But please note that this maximum addition level is not applied to casting film process. It's only applied to the blown film process. If you have the requirement for adding more than 50% for a single layer, if it's acceptable, we strongly suggest that you choose casting film process instead of blown film. Okay. So another FAQ will be easy tear. So optimize the base material for cost efficiency. So as mentioned earlier, the tear strength of the base material still plays a big role. So we strongly suggest that optimizing your PE/PP selections will definitely lead to a more cost efficiency for your packaging. So selecting the PPP with the naturally lower tear strength would require less ViviOn addition to your packaging for achieving the easy tear effect, and definitely would providing better cost-effective solution. So this is just the tear strength of different kind of PE, and higher value indicates greater tear resistance. So usually CALDPE is is the highest, and LDP is the lowest. For PP, if you want to have a better easy tear performance, we strongly suggest choosing homo PP instead of random PP. Okay, so here's the demo video for easy tear performance. And so later on, we will show the easy tear performance, which is the film is produced by the blown film process. Okay, wait a minute. So Okay, this is not too. Wait a minute. So sorry. Okay. So this is the film that is PE based, and the addition range should be like 13 or 16 to the whole structure. So at first, you can see that we have indicate the direction of this film. So on this side, it's MD, and on this side, it's TD. So usually uh, the MD side will shows um, okay. So wait a minute. Sorry, it's going a little bit too fast. So usually we could see we usually the TD direction due to the processing, its easy tier performance would be not as good as MD direction. So you can see that by TD direction, it's still straight, but not as pretty as MD direction. This, oh, sorry. Okay. Start it again. This is TD direction. And this is MD direction. So you can see that on MD direction, the tier line is very clean, very pretty, very straight. And I just want to mention this is mainly because of the processing would cause this kind of effect. ViviOn would actually brings the reduce the tier strength to both MD and TD direction. And with this kinds of difference is mainly caused by the processing. Okay, so just let me show the video again. Okay. So yeah, I'm done with my presentation today. And thank you everyone for joining this
No,
webinar. And
thank
if you
you.
have any
Thank you
questions,
very, thank you very
mhm,
much, Janice, for the excellent presentation. We will now open the session for questions. If I would like to remind the participants, if you have any question, please submit them through the Q&A chat window. We will have a few minutes to address that. I kindly would like to start with some questions as well, Janice, about
sure.
the increased stiffness. That today you said that it is the most common application. ECT is important, but as you mentioned today, the most commercial cases you have is related to increased stiffness. Do you have a comparison on how much you need to add in terms of rate of material and how much increases in PP or how much increases in PE, the stiffness of the product?
For increase the stiffness,
Yeah.
so since so for increase the stiffness, to be honest, we don't really have the data of the end product, but for providing the data for reference, we usually will show this slides to showing that. So by addition of ViviOn to PE or PP, you could see that the modulus both goes up with different kind of PE and PP.
Oh, thank you.
Yeah, and with the addition level, so by our commercialized case, the addition level for the total structure, it's lower than 5%. So for the commercialized case, we have is around 4 to 5%.
No, this is very interesting. We have a lot of customers that metallize their own film and they do vacuum metallized on CPP and other substrates. So it's very interesting that you increase the rigidity and it's easier to make the vacuum metallization. So this is interesting for our customers. Thank you.
Okay, I actually see the, okay. So I've
We have
seen
another
the one.
question from one of our customers. They say here that if your age already has a high stiffness, as you know, low tear resistance and high bear, so why do we need to add ViviOn in the film, in a packaging film?
Okay. First of all, I want to thank you for raising these questions. So I think that for aluminum-free packaging, ViviOns provides the benefits for high stiffness and reduce the tear resistance, but we don't really provide the benefits for barrier performance. That one has to be that one is thanks to EVOH. So according to our previous experience, it's true that EVOH already brings these kind of benefit, but some of the customer, they would require, they're actually comparing the packaging to the traditional consists of aluminum packaging. So they think even with the EVOH, the stiffness for them is not high enough, and also it's still hard to it's not easy to tear for their target. And usually for this kind of application, we have encountered is like the sachets for coffee, enzyme powder, and the sauce for instant noodle. For this kind of application, they are really targeting a great easy tier performance for their end customer to open their packaging easily. So I think that is depends on application if they really need great easy tier performance.
Yeah, no, I totally understand. If you compare like aluminum packaging with a pure EVOH co-extruded film, you're gonna have less tear in EVOH co-extrusion film, and ViviOn helps this to be comparable to a aluminum film, increase the rigidity of PE as well, and then you tear easier. So it's just a matter of target. I don't think we have any other question. If you have other questions, send to us. We can answer in a more appropriate time. Thank you everyone for your participation and for the very good questions. Janice, thank you again for sharing your experience and insights. I would like also to inform that we can share any of the information presented today. Please send us a message. Okay, no, just I was finishing, but we received another question here. Sorry, Janice. What's the maximal down gauging and what is the percentage rate of ViviOn does in structures? Do you have this information or can we share after all with them?
Okay, so the oh, sorry, not this. So our commercialized case is actually being applied to the collation shrink film for beverage. I'm not so sure what do you mean the maximum down gauging, but
Possible.
um,
It-
but I think it also consists of the concern for the cost. But our
yeah,
commercialized
for sure.
case is around 2 to 5%. Um, we actually have customer that using just the total ViviOn content is around this range, and they think that their original packaging without ViviOn, its thickness is 60 micrometers. And after adding the ViviOn to their formulation, they think their thickness could be down to 40 micrometers.
Which is pretty good if you consider that you're going from 60 to 40. But what I understand from your side is that the maximum was not tested yet and depends on a balance between cost and performance.
Yeah, and also depends on the customer's requirement. If with more addition, definitely it could help increase the stiffness more. And
Okay.
okay, I think I see another question. Is it applicable for other materials such?
Yeah,
Oh,
other than polyolefins like polyamide or PT.
sadly, our materials is doesn't have great compatibility with PA or PET.
Okay.
So by being the additive for the packaging, we don't have we don't target any PA or PET based packaging.
Okay. I think now it's finished. So no questions, I think. Thank you everyone again for your participation and for the questions, and it was interesting. Thank you, Janice, again for sharing your expertise. Uh, I think that's all for today. Thank you, everybody.
Yeah. And thank you everyone for participating in this webinar. And thank you so much to MPI team for arranging this webinar.
Our pleasure.
Okay.